The situation involves upgrading the electrical system of a guest cottage located 300 feet from the main distribution panel, or MDP. The existing system has several issues that need to be addressed to ensure safety and code compliance. Firstly, the cottage is fed by only 3 number 2 aluminum conductors, and there is no dedicated grounding conductor. Secondly, the electrical panel is located in the kitchen, and its clearance is encroached upon by the counter space. Thirdly, the homeowner wants to install a package unit air conditioner. Fourthly, the existing wiring does not comply with current electrical codes. Let's consider the existing grounding issues. The National Electrical Code, or NEC, requires a grounded system for safety. In the current setup, the absence of a grounding conductor poses a significant safety hazard. Installing ground rods at the cottage is not an adequate solution. Due to the long distance between the NDP and the cottage, combined with the high resistance of the sugar sand soil, the ground connection will be poor. There are a couple solutions to resolve this grounding issue. One could install a ground wire from the MDP to the cottage. This is the most reliable and code-compliant solution, but it can be expensive and difficult to install, especially over a long distance. Secondly, one could use a grounding electrode system, or GES, at the cottage. This involves installing multiple ground rods or other approved grounding electrodes at the cottage and bonding them together. This can provide an effective ground connection, but it requires careful design and installation. Now let's talk about the main disconnect. Since there is already a disconnect at the MDP, it is not necessary to install another main disconnect at the cottage. The existing disconnect at the MDP provides the required means of disconnecting all power to the cottage. Moving on to panel modifications, the existing panel appears to be inadequate and potentially hazardous due to encroaching counter space and limited circuit capacity. It is recommended to replace the existing panel with a larger, more suitable one that meets the NEC requirements. The panel should have sufficient space for all the required circuit breakers and should be installed in a location that meets the NEC clearance requirements. Now let's discuss circuit distribution. The proposed circuit distribution is generally acceptable, provided that the following points are considered. Firstly, GFCI protection. All circuits feeding receptacles in bathrooms, kitchens, and other wet or damp locations must have ground fault circuit interrupter, or GFCI, protection. Secondly, AFCI protection. Bedrooms require arc fault circuit interrupter, or AFCI protection, which can be provided by an AFCI circuit breaker or an AFCI outlet. The circuits in the cottage currently include 4 circuits. There are 2 appliance circuits, but they lack GFCI protection, which is required by code. The remaining 2 circuits feed the bathroom, living room, bedroom, and dining area. The dining area is in the kitchen circuit, which simplifies the wiring. An AFCI breaker will need to be added to the circuit that covers the bedroom. It is possible to separate the bathroom circuit from the living room circuit and re-feed from the bedroom AFCI. This will ensure that the bedroom is protected by an AFCI breaker as required by code. Now let's consider the new packaged unit air conditioner. The existing panel is inadequate and does not meet the NEC requirements. The new panel will need to be sized appropriately to handle the load of the air conditioner as well as the existing circuits in the cottage. The air conditioner will also require a dedicated disconnect within sight of the unit. Next, let's discuss the water heater. The water heater is located inside the cottage and it requires a disconnect. A disconnect will need to be added for the water heater to comply with the NEC requirements. Now, focusing on grounding and bonding, the lack of a grounding conductor from the MDP to the cottage is a significant safety concern. Installing ground rods at the cottage will not provide an adequate ground due to the distance and soil conditions. There are a couple options to resolve the grounding issue. Firstly, install a grounding conductor from the MDP to the cottage. This is the preferred method as it provides a direct path for fault current to return to the source. The grounding conductor should be sized according to NEC Table 250.122, based on the size of the ungrounded conductors. Secondly, establish a local grounding electrode system at the cottage. This involves installing at least 2 ground rods, spaced at least 6 feet apart, and bonding them together with a grounding electrode conductor. The grounding electrode conductor should be sized according to NEC Table 250.66. The resistance to ground of the grounding electrode system should not exceed 25 ohms. This can be tested using a ground resistance tester. It's important to bond all metallic water pipes, gas pipes, and other metallic objects that are likely to become energized to the grounding electrode system. This ensures that all metal parts are at the same potential, reducing the risk of electric shock. All bonding jumpers should be sized according to NEC Table 250.102. Let's consider circuit modifications to address safety and code compliance. The existing appliance circuits do not have GFCI protection, which is required for all receptacles in kitchens and bathrooms. GFCI protection can be provided by installing GFCI receptacles or GFCI circuit breakers. The bathroom circuit should be separated from the other circuits and protected by a GFCI device. The bedroom circuit requires AFCI protection, which can be provided by an AFCI circuit breaker or an AFCI receptacle. It is important to ensure that the AFCI device is compatible with the type of wiring in the circuit. Now let's address the installation of the new panel. The new panel should be sized appropriately to handle the existing load, as well as the load of the new air conditioner. The panel should be installed in a location that meets the NEC clearance requirements. The panel should be bonded to the grounding electrode system with a bonding jumper sized according to NEC Table 250.102. All circuit breakers should be labeled clearly to indicate the circuits they serve. Regarding the air conditioner disconnect, the disconnect should be located within sight of the air conditioner as required by the NEC. The disconnect should be rated for the voltage and current of the air conditioner. The disconnect should be labeled clearly to indicate that it is the disconnect for the air conditioner. The water heater disconnect should be located within sight of the water heater, or it should be capable of being locked in the open position. The disconnect should be rated for the voltage and current of the water heater. The disconnect should be labeled clearly to indicate that it is the disconnect for the water heater. The most important aspect of this project is to ensure proper grounding for the safety of the occupants. The grounding issue should be resolved by one of the methods described above, such as installing a grounding conductor from the MDP to the cottage or establishing a local grounding electrode system at the cottage. Additionally, the existing panel should be replaced with a suitable one that meets code requirements, and the circuit distribution should be modified to provide appropriate safety protection. It's crucial to consult the latest edition of the NEC and local codes to ensure that all work is performed in compliance with applicable regulations. Any electrical work should be performed by a qualified and licensed electrician. Let's examine in more detail the requirements for grounding and bonding in accordance with the NEC. Section 250.4. 8.1 of the NEC states that grounded systems shall be connected to earth in a manner that will limit the voltage to ground on the ungrounded conductors and shall facilitate the operation of overcurrent protective devices in case of ground faults. This means that the grounding system must be effective in providing a low impedance path for fault current to return to the source, which will cause the overcurrent protective devices, such as circuit breakers, to trip and clear the fault. Section 250.24 requires that the grounding electrode conductor for a separately derived system, such as a generator or transformer, be connected to the neutral point of the system. In this case, since there is no separately derived system, this requirement does not apply. However, if a transformer were to be installed at the cottage to provide a different voltage, this requirement would need to be considered. Section 250.50 requires that all grounding electrodes that are present at a building or structure be bonded together to form a single grounding electrode system. This includes ground rods, metal water pipes, metal building frames, and any other electrodes that are available. This bonding ensures that all metal parts are at the same potential, reducing the risk of electric shock. Section 250.52 specifies the types of grounding electrodes that are permitted by the NEC. These include ground rods, metal water pipes, metal building frames, concrete encased electrodes, and ground rings. The choice of grounding electrode will depend on the specific site conditions and the availability of suitable electrodes. Section 250.53 provides requirements for the installation of grounding electrodes. Ground rods must be at least 8 feet long and must be driven into the ground until at least 8 feet of the rod is in contact with the soil. The tops of the ground rods must be flush with or below the surface of the ground, unless they are protected from physical damage. Section 250.64 provides requirements for the installation of grounding electrode conductors. The grounding electrode conductor must be sized according to NEC Table 250.66, based on the size of the ungrounded conductors. The grounding electrode conductor must be installed in a continuous length, without any splices or joints. The grounding electrode conductor must be protected from physical damage. Section 250.104 provides requirements for the bonding of metal water pipes and other metal piping systems. Metal water pipes that are used as grounding electrodes must be bonded to the electrical system with a bonding jumper sized according to NEC Table 250.102. Other metal piping systems that are likely to become energized must also be bonded to the electrical system. Section 250.118 specifies the types of equipment grounding conductors that are permitted by the NEC. These include wire-type equipment grounding conductors, metal raceways, and cable trays. The equipment grounding conductor must be sized according to NEC Table 250.122, based on the size of the overcurrent protective device protecting the circuit. Section 250.122 provides requirements for the sizing of equipment grounding conductors. The equipment grounding conductor must be sized according to NEC Table 250.122, based on the size of the overcurrent protective device protecting the circuit. The equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. Section 250.130 provides requirements for the use of ground fault circuit interrupters, or GFCIs. GFCIs are required in all 125 volt, 15 amp and 20 amp receptacles in bathrooms, kitchens, and other wet or damp locations. GFCIs are also required in all receptacles that serve countertops in kitchens. Section 210.8 provides requirements for the location of GFCIs. GFCIs are required in all 125 volt, 15 amp and 20 amp receptacles in bathrooms, kitchens, and other wet or damp locations. GFCIs are also required in all receptacles that serve countertops in kitchens. Section 210.12 provides requirements for the use of arc fault circuit interrupters, or AFCIs. AFCIs are required in all branch circuits that supply dwelling unit bedrooms. AFCIs are designed to detect arc faults, which are a common cause of electrical fires. Section 406.4 provides requirements for the installation of receptacles. Receptacles must be installed in accordance with the manufacturer's instructions. Receptacles must be securely mounted and must be properly grounded. Section 408.36 provides requirements for the labeling of circuit breakers. Circuit breakers must be labeled to indicate the circuits they serve. The labels must be legible and must be permanently attached to the panel. Section 110.3 provides general requirements for electrical installations. All electrical equipment must be installed in a neat and workmanlike manner. All electrical equipment must be installed in accordance with the manufacturer's instructions. All electrical equipment must be properly grounded. In summary, upgrading the electrical system of the guest cottage involves addressing grounding issues, panel upgrades, circuit modifications, and safety protection. By following the requirements of the NEC and local codes, the electrical system can be made safe and reliable for the occupants. It is always recommended to consult with a qualified and licensed electrician to ensure that all work is performed in compliance with applicable regulations.